Good morning. It's quite amazing to see such a big hall filled with our customers, shipbuilding customers. In the user meeting in Hamburg, Wave was our big announcement. But back then, we didn't really have anything to show apart from nice, glossy presentation and PowerPoints. So I have you for the next 90 minutes with my colleague Aleksi to really take you through some of our ideas for that. Aleksi will be doing the main presentation for Wave. I will be following up with a selection of things about what we've done recently with eShare and the vision for the future. But I'd like to start out by focusing on information management in shipbuilding. I think in the time between Wave becoming much larger than it is today, a point where we can actually show you more of what we're doing with customers, the time is right to talk about the relationship between PLM and shipbuilding. So, this is a very much approximate review of research. Shipbuilding software has really matured over the last 60 years. Certainly there was a lot of early development done in the 1970s, but now, we kind of got into very much a mature idea of what we need to do with CAD in shipbuilding. And yet, in my lifetime within the software, PLM has come along, and it's certainly been a challenge for me. Why is it important now, after we have had such a long time understanding where shipbuilding is going? And it's been quite a problem. You, the customers, have challenged us to deliver PLM. And quite frequently, not all of my lifetime was spent with Cadmatic, but also with other CAD softwares, we've often failed to win your business because we couldn't live up to your expectations of what PLM was. I think that's still a challenge today. But we've also seen some unsuccessful implementations across industry. So it's clear that there is still a big challenge about the relationship about where we have our expertise in shipbuilding and in the CAD systems, and what PLM brings to that relationship. So I think the key thing to do is to understand the principal drivers behind what PLM brings to us in shipbuilding, to the shipbuilding software, to try not to make the most complicated solution. Because I do see that happening a lot. So being pragmatic is a really important component to what I'm trying to bring to the message with my presentation. So I'm trying to bring more than good intentions to this presentation. I don't really want to spend my time saying you should work faster or work smarter. I want to give you something that you can take away back to your companies and say, I think I understand it now. The challenge is that change is constant. 100 years ago, we were drafting with pen and paper. If you needed to remove something, you had to etch out your vellum, your tracing sheet. Those designers were not thinking about digital twins. They hadn't even been invented. Even in Cadmatic's lifetime, I found this image in a really old user meeting presentation. They were not thinking about being able to design electronically. So perhaps now, we don't know what the future brings. We've got to come up with it. More recently, we've been bombarded with a lot of disruptive messages. Even with these, I don't know how you go back to your desk, to your engineering business, and put this into practice without actually really getting to something that is important to you. And that's where I want to go. Things that are important to you. So, now, what is the big question for information management in shipbuilding? What is the point? What are we trying to get at? And I feel that the kind of principal challenge when you talk about engineering information is the question of, is it mature enough to support production? Now, even this isn't a weighty sentence until you consider the fact that if you are using immature information in production, that could mean that you have to throw away the materials. That's a cost. You've delayed the project. So making sure that you get information mature enough to start production is probably one of the most important elements of what we're trying to achieve within the design process and feeding that through into production. Now, I don't want to forget the other things that come up in terms of the big questions. For example, things like reusing your engineering information in the next project. You've invested a lot of time to make it mature, why not reuse it? And then we get on to subsequent challenges, such as delivery of multiple copies of the same design, sometimes called sister ships, hull applicability. They are different processes. And then we move into the operational phase. How do you maintain your equipment and your systems? How do you go about reordering replacements, dealing with the situation when equipment becomes obsolete? In fact, within our industry, I think we are challenged to move from the first idea, the engineering production, into the operational phase. I've not met many shipbuilders that really have addressed this challenge. They kind of leave it to a support team. So I think there's a lot of work to be done there. But as we're shipbuilders, let's focus on the first message, maturity in shipbuilding. So a long time ago, I went on a delivery voyage, cruise liner. It was the biggest ship I'd ever been on. So many bits. Let's pick the smallest bit. Now, I wanted to pick a bracket, but I couldn't find a photo with a bracket. That is, in fact, a panel. But for the moment, let's say it's a bracket. And at some point in that bracket's life, the designer had an idea and wanted the bracket there. Now, that bracket has to go on a massive journey, which is probably unique to shipbuilding. We build a unique vessel consisting of, well, who knows how many parts? No one really is counting because we just know there's a huge amount. And then you go to a shipyard and you go, well, where is my bracket? And that kind of sums up the information management challenges. It goes on such a journey, and, well, my colleagues were telling me yesterday that sometimes they do lose bits of ships. I'm kind of surprised. I thought we had that one. But let's go back here. What do you want us to do? Well, if we take that bracket, you want us to change the radius, update the drawings. Move the light, update the drawings. Delete the grill, update the drawings. This is a message of constant change, not maturity. Well, of course, we get a new hull surface. We want to update all of the structure associated with that hull surface. Now, sometimes we get really challenging questions in user meetings. I want to move the deck and have everything update, all the equipment, all the systems associated on it. If you imagine the amount of stuff, the amount of data on the deck, it's a very easy line to give us as the software developers. And maybe it's technically feasible, but the impact on the design, the maturity, and even the impact of us making a mistake, it's kind of a heavy problem. So touching on that point of change, if we go back to the evolution of shipbuilding, where did we start? Well, back in the 1970s, we saw the emergence of numerically controlled machines for plate cutting, pipe bending. We needed electronic information to power this. That didn't come until we had things like mathematical representations of the hull surface. Because, well, the origin of the data had to start somewhere. From that, we could build our parts. And remember, in the beginning, we started with punch cards and coding, not visual design. From our parts, we could go on to produce our part outputs. We wanted them generated automatically. And then on to our digital manufacturing process. And what we have here is a really neat process of a value stream where you can make a change, it's data-driven, get automatic updates. We were working with databases in the 1970s, so often the idea of what PLM, the challenge that it was originally designed to address, which was file-based systems, doesn't really apply to us. We solved that problem years ago. But we didn't stop there. We went on to produce other outputs like drawings, 3D models, calculations. And then somewhat later, we got on to visualization. I'm told my older colleagues had to wait overnight to get a picture of what they were designing. But now, it just appears. So we work on our visualization. We do visual assemblies that can feed into our E-bombs and our M-bomb processes. But ultimately, shipbuilding tools have had a great focus on producing outputs. And if they're generated automatically, well, there is no pain to make a change and propagate that through. It's great when you're an engineer, you can just produce all of this information. But it does have an impact on the other stakeholders in the process, especially when you start thinking about a digital twin, a single source of truth. So let's talk about our overall shipyard. We know that if everybody is working in this digital twin, there is only one in this respect because we call it a single source of truth. We know that we'll start having a plan, and some parts of our design will be mature. They're already being constructed. There are other elements that are not needed right now. They'll be immature. Some elements can even be conceptual. We haven't started yet. And that idea of change through the software creates a bit of a challenge because engineering start making a change, but production can see the single source of truth. They can also see engineering working on the changes at the same time. And I've experienced this with some of my customers many years ago. It was the first time that the customer deployed 3D into the production environment. Production started making things that engineering were designing at the same time and then got unhappy when the thing that they were building was not ready for use. So you have this problem is, what is mature? And then you have the planning team that are in the interface of all this process, and they can also be quite unhappy, really not understanding what is going on. So this idea that we have of very efficient change in our design systems does cause a bit of a problem, and this really opens up that idea of where we can introduce PLM. It is somewhat about slightly reframing the problem. Instead of propagating change, kind of need to stop that. And think more about the idea of publishing. It's just a word, but it comes with a bit of a message. The act of publishing implies maturity. I'm saying it's ready for use. The idea of revisioning and versioning delivers incremental updates to that maturity, approved, but overriding what is previously done. But the ultimate end users don't see constant change in that information. The designers, the engineers, they can work with a working version, effectively a private configuration that no one sees. It's not ready for consumption until it's published. So therefore, you can say project information should not be used until it's mature. So you have the idea of maturity and immaturity. Now, you could make this more complicated. You can go on and formally define what maturity means in terms of writing processes, qualities, reviews, sign-offs. But let's leave the formal stuff for another day. So this really, in terms of making a pragmatic solution for shipbuilding, really it highlights what we can use CAD for and what we can use PLM for. I already highlighted that a majority of the things we're using the CAD for is to make outputs. Therefore, publishing approved version of these outputs is a very logical solution. And you'll see in Aleksi's presentation, that's primarily what we focused on in this first iteration of Wave. Subsequently will come the parts, again, a publishing process. That creates some complexity for us if we start diving into topology, but if we were to keep it simple, then there's some straightforward ways of going about that. But then later on, I don't exactly know when we're bringing this into the software, will come information such as groupings, especially the assemblies. The assemblies are the essential, effectively, identifiers that work with planning and production to really deliver that ship. So, for example, making a visual assembly in the CAD end, the visual end of the software, propagating that through into the PLM system, which then becomes an EBOM, which can subsequently be reviewed into an MBOM, really, again, gives you a nice, simple process. So, going back to clarify those roles, the CAD system has always been asked to generate and deliver a rapid reconfiguration of information to make the updating of those outputs quick and powerful, whereas PLM is about securing the configuration from one stage to the next as changes are made. Have a fast response in the CAD system and a slow change in the PLM. immaturity in the CAD system, consolidation and control in the in PLM, giving you maturity. Now, choosing to work with a PLM system gives us a bit of an advantage because the only alternative would be to slow down the shipbuilding system. And this would put the requirements on the shipbuilding to be able to both propagate change efficiently and stop it at the same time. I think this would be an administrative nightmare. So choosing two separate systems really does kind of neaten up and makes a nice, sensible solution. We call this Wave. Wave isn't the PLM. Wave isn't a particular piece of software. It's the entire software solution brought together with a shipbuilding focus. So ultimately, what are we contributing to this if it's not about the software? It's really about accelerating the adoption. We are already taking two mature systems, our own software, Cadmatic, and the Contact PLM system, and we bring into that our expertise. Especially Atta and Aleksi are doing the main work in making this happen. And they are achieving 4 things, particularly the system integration. There will be software to assist the publishing processes that work between both the design apps and Cadmatic PLM. They are building data models that represent shipbuilding so that you don't have to start with a blank sheet when you start the PLM building process. That associates with all the processes that you have to go on. But the important thing is that there is an ideal to templatize the entire process. Why? So that once we get a mature data model, mature processes, when we head to the next customer who's interested in PLM, we can just reproduce our expertise without taking a lot of time to make the implementation. So if I was to summarize this process, it's really all about maturity. It's really about preventing uncontrolled change being seen by people who want security in knowing that the information they're using, production planning, is really ready for them to use. But if you then take a step back as perhaps a manager of that process, when you can see maturity, you can also see immaturity. You can tackle that to address the project becoming more mature. And you can then also use your experience to understand those things that might be missing and might be gaps. Bring that into the process. And ultimately what we're really doing here is exploiting the technology to build this between the two systems to allow you to get there pragmatically. At this point, I shall hand over to Aleksi, who will take us on through the next phase.